an operation like adding or subtracting, of course I can always look at these and cross multiply. Like 8 times 8 and 5, 8 times 5 is 40ths, so 40ths isn't too hard. And I can see that 5 times 5 and 8 times 4, those are all numbers that I can do to cross multiply, so I probably am going to make this just 40ths. 5 times 5 is 25, plus 8 times 4 is 32 40ths, and now I need to add those across. So 25 and 32 is 57, 57 40ths, and I'm requiring students at this point, they have to reduce this, they have to change it. When I say reduce in this case, it needs to be made into a mixed numeral. So 1 40 goes into 57, and there will be 17 40ths left over. And I know that's true by just working it backwards. 1 times 40 is 40, plus 17 is the 57, and the denominators stay the same there. I'm teaching students to circle their final answers in this case. Let me see, I'm going to show you the trickiest one here. It's 4 and 14. Students might think, oh, I've got to multiply 4 times 14. But is there something that you can count up to, a multiple of 4 and a multiple of 14 that's going to be a smaller number than 4 times 14? Yeah, it's 28. If I multiply this by 7, I could make 28 on the bottom. What I do to the bottom, I have to do to the top. So my top here is 21, and the bottom here is 28. 21 28ths is the new fraction. I could even do this if that helps. And on this side, if I double the 14, I get 28. And so that means I have to double the numerator. I get 8. So now I have 8 28ths, and it's being subtracted. 21 28ths is being subtracted, or excuse me, 8 28ths is being subtracted from 21 28ths, and I can do that in my head. See, it's going to be 13 28ths, and I know that that's a reduced fraction because these don't share any common factors. 1 times 13 is the only thing that makes 13, and 13 doesn't go into 28, 1 does. So whenever I get a prime number up here on my numerator, that's a good sign it's probably a reduced fraction. As students look over this other one here, they might be tempted to go 12 times 3, but why not just change this one here into a 12? And I did that by multiplying by 4, so I'm going to take my numerator and multiply it by 4, and it's 8. And when I get to doing that, I just have 1/12. Now, and that is certainly a reduced fraction because I can't make either of those numbers smaller by the same factor. Over here is the same one again that's going to be 50. Again, 250 will work, but it's going to take a long time to make 250 work. On the top up here, 6 times 4, 24 works, but 6 goes into 12 and 4 goes into 12. So 12 is going to be an easier number to use to solve that. Down here on 9 and 6, 9 times 6 is 54, but 2 9s is 18, and 3 6s is 18. So you might want to use 18s down here. Anyway, this is how to use cross multiplying to add, to compare, or subtract fractions.